Hey, Vsauce, Lipschitz here. How does your car move? Well, with a bunch of pistons and valves letting in fuel and oxygen and burning the mixture up. But what is the science behind the engine powering your car?
Extracting solar Lipschitz.tar.
Easy. Okay, so there are many possible engines that might be powering your car. Your car might be powered by a diesel engine, or a hybrid engine, or an electric engine. You might even have a hydrogen car, which literally uses rocket fuel. Your car might even be powered by love. It's what makes a Subaru. But let's go places to find new roads, or in this case find old roads, and talk about the ultimate driving machine, the OG car engine, which is truly an innovation that excites. We're talking about the internal combustion engine. Now, internal combustion engines, or ICEs, are extremely efficient, except I'm being sarcastic, because an entire 30% of the energy produced is produced as movement or kinetic energy, the rest as heat. Wow. But how do they work? In order to find out the science behind ICEs and how they work, we're gonna have to shrink down to the quantum realm. Well, actually, we're going to the molecular level because we're seeing what happens between the atoms, but I'm trying to infringe upon as many copyrights as I can in this video, so quantum realm it is. The first thing you'll notice in the quantum realm is that the ICE uses a chemical reaction to run. You can tell by the atoms rearranging themselves into different molecules. Well, actually, we haven't started the reaction yet, so you won't notice that yet, but we'll get to that soon. Now, the type of this reaction will seem very counterintuitive and will be very surprising, so make sure you're seated, because I don't want to get sued for any deaths from heart attacks. Due to the reactions being hydrocarbons and oxygen, and the products being carbon dioxide and water, the reaction in an internal combustion engine, you can say drum roll please. Combustion reaction! Shocking! Now, the actual first things we'll notice are the reactants, or original substances. In our case, we need octane, or C8H18, and oxygen, or O2. We're going to need 2 octane molecules and 25 oxygen molecules for this reaction. Both of these molecules are held together by the weakest type of bond, covalent bonds, where the atoms share electrons. Next up, let's begin the reaction. So how do we start this reaction? Well, we need activation energy to light the fuse. Quite literally, in order to break the bonds, we need to light it on fire! Now, let's look here to watch the reaction. No, not the reaction to the Super Bowl winners, the ICE's chemical reaction. Yeah, I know I'm not very fun, but let's watch. When the bonds are broken, new ones will be built, so the atoms will be in different molecules. This will give us the product or substances we end up with. In our case, the products are carbon dioxide or CO2 and water or H2O. We will have 16 carbon dioxide molecules and 18 water molecules. Also, this reaction releases more energy than is required to start it, making it an exothermic reaction, which sounds like a really cool heavy metal band name. These molecules have polar covalent bonds, which are a little bit stronger than regular covalent bonds. This chemical reaction has the following equation, which you can see right there on the screen. The equation is balanced as the reactants and the products both have a total of 16 carbon atoms, 36 hydrogen atoms, and 50 oxygen atoms. Or, as my friend Thanos would say,
perfectly balanced, as all things should be.
Hey Thanos, you want to snap this time? Here are my powers for a few seconds. Whoopsie, and as always, thanks for watching.